Hello everyone, and thank you for joining today's webinar on the newly released Athena Impact Estimator for Highways tool. Estimator for Highways tool is a new software package based on proven lifecycle assessment models and to allow transportation engineers and roadway designers across the country to easily measure the environmental impact of the road design. The beta of the tool was extensively peer-reviewed and decided by DOT consultants and academia representatives, and to present to you today the fully commercialized version. To download for free, please visit athenasmi.org. Today are Chris Gomans, who will provide an overview of the application's functionality, methodology, and life cycle assessment data, and who will walk you through the program. Question, please send it to me through the chat box. At the end of Grant's presentation, we'll have lots of time to answer all of your questions. And the microphone over to Chris and Grant.
This is Chris Gomans and Grant Finlayson with the Athena Institute. Today, we're with the Impact Estimator for Highway software. We'll spend about 15 minutes walking through a brief overview of the Impact Estimator, an overview of the MIT Pavement Vehicle Interaction model. Then Grant will walk us through a demonstration of using the tool, and to have about 10 minutes for questions and answers. So please refer your questions to Sherry via the chat utility, and she'll pose them to us during the Q&A segment. This is a membership-based profit organization focusing on the lifecycle assessment of the built environment. We work with organizations in the construction sector, doing for building materials and developing LCA-based tools for designers. I'm a software and database developer, and I'm responsible for maintaining the Institute's web presence and its IT infrastructure. He is a specialist in LCA assessments using the Impact Estimator software tools and is a lead researcher on a variety of LCA projects. He is additionally responsible for programming, testing, and evaluation of the Impact Estimator software tools and provides support and maintenance for building assemblies. Why do you want to apply it to roadway design? America has a significant infrastructure deficit, even after all of the recent infrastructure stimulus funding. Most infrastructure was built during the 1950s and 70s and has subsequently used up about 79% of its service life. Increasingly resource-constrained world due to a slower-growing economy, an aging population that translates into a smaller net tax base to draw from, and a large population drawing on fewer natural resources. Implications of that are that we need to do more with less, and we need life cycle performance. Various industries, when they are serious about reducing environmental footprint, we can't reduce our footprint if we don't know what kinds of impacts we have, how big they are, and what hot spots are. Many use LCA to reduce footprints of products. Designers use LCA to reduce footprints of their products as well, which would be buildings, highways, etc. If we don't use LCA, we're just guessing what sustainable is and what it isn't. We also tend to focus on a single issue or a single life phase. We may therefore be missing a major part of the equation. We may be addressing short-term improvements while incurring long-term damage. We may be fixing the wrong part of the problem. We may be shifting our environmental burdens from one phase to another. Here's a LCA diagram courtesy of our colleagues at MIT. Life cycle stage does not come into play, as we consider roadways to be permanent pieces of infrastructure that undergo maintenance and rehabilitation into the foreseeable future. The Impact Highways was originally conceived of in 2009 and has been underdeveloped ever since. The version was released in spring 2011 and was led by the Environment Canada and the Cement Association of Canada, with highway engineering expertise from Morrison Hershfeld. The commercial version was released in May 2013 and was funded by the Cement Association of Canada. For highways, the tool could be used to model life cycle effects, or roadway cross-sectional design. LCA results for product manufacturing, roadway construction, use phase, and maintenance life cycle stages. It allows roadway design, but also comes with a library of existing designs that can be used as a launching point for a new design, or can be duplicated and the duplicates modified. The data library roadway designs cannot directly be altered by the end user. Rather, users can use the database library designs as starting points, as I just mentioned, by either loading and duplicating the sample project version of the library, or bringing new roadway designs and choosing a library design from the scenario drop-down list. Grant will show during the demonstration. Allows users to use phase roadway operational energy consumption and pavement vehicle interaction action effects. Use two buckets, due to PVI and roadway operational energy consumption. It also has LCA results for manufacturing, construction, maintenance, and technical stages. Plus roadway materials in the growing. Of these, there are 40 component materials for which we have regionalized LCI data, and the rest, like asphalt or cement concretes or admixtures or a variety of custom mixed designs, the component materials. Use and save customized product mixes. Make as many custom products as you want and save them in a user-defined custom product library. Material by transportation modes and distances customizable. Materials can be regionalized to local transportation and energy grids. Large equipment database is customizable to reflect the regional and seasonal working conditions and usage rates. Include above or below ground material infrastructure, such as culverts, bridges, etc., and does not include preparation or excavation, which appear to be common to comparable road types and designs. Transportation data are derived from proprietary Athena databases, as well as U.S. Lifecycle Inventories database and EcoInvent database. Materials national or industry averages for the extraction, processing, and manufacturing of materials and products. Regional energies and transport distances are then to manufacturing process energies and material distances to arrive at regional data profiles. The support indicators are based on the U.S. EPA Tracy 2.0 methodology characterization factors: renewable fossil fuel consumption, global potential, acidic potential, human health emissions, eutrophic potential, ozone depletion potential, and smog formation potential. What exactly is pavement vehicle interaction anyway? The PV is based on the latest research and model from the Concrete Sustainability Hub at the Massachusetts Institute of Technology. Here it helps to visualize the two components of PVI: deflection, the tires to constantly be rolling uphill, while this causes the tires to experience a roll along the roadway surface. PVI is a function of roadway deflection and surface roughness. Both depend on the makeup of the top layer of pavement on the roadway surface. It demonstrates possible increase in vehicle fuel consumption and relates effects associated with the pavement performance over time. It does this by contrasting the pavement's roughness and its deflection over time to a theoretical rigid and smooth roadway, thereby on the effect of the pavement's performance, not the life cycle vehicle effect. For passenger vehicles and trucks, the influence of progressive increases in roughness and deflection of the roadway top layer over time, measured between major rehabilitations, and interpret calculated decline in performance as vehicle fuel use pavement characteristics. The P inputs include the following: length, average speed, represent the start and end years between major rehabilitation events, the International Roughness Index values for each time segment, plastic modulus, thick density average values for each time segment, vehicles, which would be vehicles, traffic, expected ending of the project, and the projected annual growth through the end of the project lifespan. Possible fuel consumption increase and related effects associated with the pavement performance on a per vehicle basis. Passenger vehicles and trucks, again, are based on federal vehicle classes. For vehicles projected to be using the roadway during the projected lifespan, the default for projected lifespan is 50 years. Dependent on average vehicle fuel consumption and physical characteristics. The dependent type characteristics, in particular the average fuel consumption, lack of quality fuel consumption data by vehicle type at specific traffic speeds is an area that is presently being looked into by our colleagues at MIT. Efficiency in the data upon which the model is dependent. Number of one-off pavement reports. To our knowledge, it has never been incorporated into a commercial software tool. Unlike life cycle inventory for materials, plant operation, and construction, which have been studied at length and for which there is considerable literature, it is relatively new and represents a forecast or future state scenario. Scenarios with it a degree of uncertainty that needs to be duly considered. Uncertainty would be best handled by using a statistical probability approach to the calculation model and the data, something that this tool does not offer. Hence, the incentivizes those using the results from this PVI module to always acknowledge this uncertainty when discussing or presenting these results. More recommend that when using this module, users complete a sensitivity analysis and err on the side of reporting conservative results in any public representation of these results. Now, control my Pendleton. Here we're going to switch. Everyone can see I've got impact open. Yeah. That's what's showing on another computer, so I think we'll go ahead. This is what the program looks like when you open it up. It's a blank at the moment. I have projects already preloaded in here, but when you do open it up, these wouldn't be loaded here. These are two of the sample projects that are available in the tool in a moment. Are four of them, all model based on an Applied Research Associates report on Ontario municipal roadways. And it's sort of self-described in the title here. Here we have Ontario Municipal Major Arterial, PCC or HMA road with a 10,000 truck traffic number and a subgrade modulus of 50 MPa. And so that's sort of the high go down to 250 AADTs with lanes and 30 MPa subgrade. And it ends up being 48 of them. They're pre-included when you install software. And in the next edition, there's going to be conversions added in, 96, I believe. And sort of a wide range of municipal roads that are pre-built. But everyone an idea, the old program, I'm going to start from scratch. So I'm going to go up here and click on this icon and it's an add a project, or you can go into file and choose new. And this is the
what you have here, what we call our project level data. I'm going to get a name. Choose a location. Happen to be in Ottawa. I'll choose Ontario East, but these are our Canadian regions that are supported. Across below territories, I guess. Because that chooses the regional energy grids and transportation grids for the materials that Chris talked about earlier. The Ontario electrical grid to our manufacturing processes, if we chose, and that will affect our end results in a big way. Quebec, for instance, is 90% hydro in Quebec, but in Ontario you get into natural gas and nuclear and hydro production. In Nova Scotia or Atlantic, you get a lot of natural gas and coal, so it affects the results. The other thing to decide here are the project lifespan. It's defaulted at 50. You can go as low as 30 if you want, and as high as 1,000, but we defaulted at 50. The average distance to stockpile here. This is a number for recycling materials and removing them from the road and carting them away during a rehab step. That's the distance that we want to, that we're transferring to disposal. So we're going to be relating that to transportation energy in those steps. Average distance from plant to site. This is for the concrete and asphalt plants to the site. It put in there as an option in the if you wanted to model plants that may move along with the project or so forth. If you're doing a long project, and it's defaulted to 30, and you can put in whatever number you want there. And we distance of equipment depot to site, and that's the average distance that you're going to be floating your equipment from the wherever to the site itself. Down number and project description. These are just places to make notes for yourself. That's the basic project level data. At the top we have some other steps, which I'm going to just quickly do, but I'm not going to go into any details right now. This is, as Chris said, we can customize our construction equipment energy usage. We have a transportation table here. Again, you can customize if you know where your transport materials from. The manufacturing stages, that's here. And a roadway operating energy consumption, where you can input any total number for these files if you want. For instance, if you wanted to put in the life of the road on an annual basis, you put in X number of kilowatt hours of electricity to the road, and burning these fuels or using these fuels will be calculated and incorporated into the results. I'll probably go construction and material transportation a little bit, maybe just show a couple of the details. We've created a project, we've done a location, and you see here I've got a new project added in my project here. All to do is to create a roadway. So I'm just right click on demo here, and a little box pops up, and you see down here we have add roadways. So we're going to roadway, click on that, will pop up. This is our design docs. We can give it a name. We can call it whatever we want. I'm going to make this, let's say, an HM. We have this here. You can create your own scenarios and save them, but we also have ones. And these ones that are preloaded are 48 that are available as full sample picks. Choose one of these from this list if you want to quickly start a project and then modify it. But I'm going to start scratch here, and then we have to fill out a bunch of these boxes. So we have initial cost. I'm going to do a 1 lane length at 2. I'm going to pavement lift, and I'm going to say there's 1 granular layer here. Simplicity with this example, you can pretty much any number of lifts and granular layers. Flexible pavement or rigid pavement, you can choose both. If, for instance, you're doing a PCC, a concrete road, but you've got asphalt, you can choose both. But for this case, well, choose rigid. There's also input box here for reinforcing steel. Design tool, so it's not going to calculate the amount of steel you need. You have to know that yourself and then put it in tons. For this example, we'll go with flexible pavement. Here we have our right and left side elements, the shoulders and ditching and so forth. I'll just do one side, the left side. I'm going to say that it has a shoulder. It also has a paved shoulder. I'm going to say there's 1 lift on that shoulder, and I'm rounding of some granular or material quantities according to that. So the basic information for our roadway, I'm going to click apply, and see a schematic shown up here. So here our left side elements that we just put in has paved shoulder, it has an unpaved shoulder, it has rounding on slope. It's not it's not actually on 4:1, but it's listed here. It's at 4:1. With 1 lift each, and we have a granular layer under the whole thing. Sure, just to make sure you've not added something in you didn't want to, or that you're not missing something that you want to. Now we need to choose materials for each of these elements. So we have 1, 2, 3, 4, 5, 6 elements there. We have 1, 2, 3, 4, 5, 6 elements down here. So if I click on, for instance, granular layer, if I click on there, it's highlighted here, or I can click on it in the table down below. And I'm going to select a material, the granular layer. And there's a bunch of these that are in the database. So we'll choose, let's say, gray for that. I'm going to give width. And not quite sure what these, let's 15 meters wide. Thickness of 400 millimeters. With, you see, it gives you the density from that number in the database and the mass of that material. Go down. Now we have to populate the other one, so we'll go with 2 lanes. And I'm going to say that it's on HMA Super Pave 12.5 FC2. This custom product that we designed for these sample products, and I'll show you how to do that later. Of meters wide, a thickness of 2 millimeters. Same. 2 lift 1. I'll go choose the same. Since they're both in the same lift, it's assumed the same thickness. But change that if I want to. If for some reason there's would be different. Of course, there's no reason they would be different. At 5 meters as well. Left side round. I'm going to choose a material, so let's go with granular B type 1, for example, a width with a thickness of, well, let's go 1/5. This is density and mass again. And shoulders and unpaved shoulders. Asphalt, right, let's say 150 thick, and shoulder, and with granite B, 2 meters wide, and yeah, 150. So on these thicknesses, let's say, for instance, if you had these two lifts with a different thickness that says, you know, that should happen. It's to make sure they're correct, and but it is possible to miss something there. Okay, so we've designed our roadway, basically. These are our lanes and lifts, and okay here and save that. And there's an error message here to do with the PVI effects. I'm going to come back here, so I'm just going to ignore that for a second. And so, the roadway, we call it HMA demo. To case and you have to get it back in. And the same thing comes up here, and you can edit this any way you want later on. The next thing to do is do a rehab schedule. Add steps to the rehab schedule. And when you click on the tab at the top here, rehab schedule, blank at the moment, and I'm going to click add, and this pop up. You fill out these things again. So we're talking HMA road, so let's say after 15 years, mill and resurface rehab steps. So saying after 15 initial construction, and we expect it to last 15 years, I'm going to do an asphalt partial depth reclamation, let's call it. We can put in a cost for it, $40, description, partial depth reclamation. You want to do the lanes and the shoulders, or just the lanes? I'm going to do just the lanes. How much road we are going to rehab. So, for instance, with the partial reclamation, we're going to do it as part of a percentage of the surface area. And let's just say we're doing the whole thing. So it's 100% of the surface area. When we we've got 10 squares that we're going to reclaim, and that's related from the lane widths. We road width with two paved lanes of 5 meters each, so that's 10,000 square meters. Pick a number of sort of default activities, and you don't have to apply each activity to the rehab. So for simplicity in the example, we're just going to say we're going to skip them all, excuse me, skip except asphalt paving. So here, asphalt pavement, I'm not skipping that, so I'm leaving that blank. I'm going to remove material here. Material I'm moving, so I'm selecting an HMA pavement, which would be SC2 12.5. I'm going to let millimeters of that, and I'm going to add that pavement back in too. So I'm going to add material, select HMA pavement, same pavement, and I'm adding millimeters back in. If I click OK here, it ends the table. If we need to edit, we can go over to the left-hand side, and that pops up the box there. That's how we do a route over 50 years is a whole bunch of rehab steps, and I'm going to show you the complete files in a minute. But once you finish your rehab, the next you go to your PVI schedule, and this MIT study or model that we've incorporated into here. It requires information from you that you knew about. This NOR PI effects. I'm going to unclick that because that was the error message I got before. It was telling me I had not completed this section. If you don't complete that section, you can click that button and leave it on, but we're going to do it here. So we go to the PVI section, and we're going to say with the first basic needs to be input for every major rehab or rehab when you change the surface of the road. put in a mill and repave step at 15 years. So I'm going to say for the first 15 years, fault, which let's say is top elastic modulus of 10K, was 150 as the top thickness, but that's probably an unrealistic number. Let's say it was 40 as a top layer, and we moved 40 and replaced the 40. Density. Now, when we product like that, we can do the density. This one happens to be 2.52 tons per meter cubed. Like these roads up here, we have 30, 50 PA type roads in the sample project. So let's make it a 50 for the site. And then we have the IRI and the final IRI index at the initial years and the final at 15 years. And a perfect road is about 0.5, and the worst road possible is about 6. But these seem to be sort of typical numbers. You start off with about a 1, and when it gets 3, they start thinking about having to resurface. So I'm going to use those numbers here. Another step down here. So we've done rehab at 15 years. We need to do a new section for the next period, and it would probably be another 15 years, but we've just an example here so far. So let's just say, for example, it lasts a 50-year lifespan. I'm using materials with the same thicknesses, so it's all the same numbers in the second row. Level, and again, when you redo, we're restarting with an IRI of 1 and finishing with 3. And your down here we put in a truck or vehicle usage data. These sample projects only have traffic as considered. So I'm just going to go in here with trucks, and let's say it's 10,000 daily traffic with a growth factor of 1% a year. And completed our PV input. And like every major rehab is going to have to have a row up here for changing IRI scenarios. So on the PVI, we've completed our PVI, we've completed our rehab, let's say, and we've completed our design. And I click OK. And we have our road, and basically we're ready to look at some results. I'm going to click Save on here for that now. And then I get this demonstration. I'm going to file up here to one of the included sample files, which is Ontario Arterial Road, HMA, with 10,000 daily truck traffic and a subgradulus of 50 MPa. I'm going to click Roadway. This report, roadway design, did not have any shoulders or roundings on them. So you see here, we just have a simple 4 lanes with 2 lifts and 1 middle layer. Pardon, middle layers. These things are populated. The whole width is a 16-meter road. We've got 2 outside lanes at 4.25, 2 inside lanes at 3.75. We've got 2 granular at 500 and 150 millimeters thick, and we've got 2 layers, 2 lifts of pavement at 140 and 40 millimeters thick. So it's the same thing as I just showed you, but it's and I go here to schedule, and there I can schedule according to that report that we talked about. So at year 8, we've got spot repairs and route and seal. At year 13, we've got spot repair and route and seal. At 18, we have a full depth repair with a 50 millimeter mill and a surfacing. At year 20, route and seal, spot repairs, route and seal 28 years. Refill at 32 years with and resurface, a route and seal at 37, et cetera, et cetera. And that's sort of the complete rehab for this road. And we've got vehicle interaction here, and PV section here, and here it is. Between each of those mill and repairs and resurfaces, at 18 years, at 32 years, at 45 years, we have in the RI. So we're starting at 1 and ending up at 3. And we have the truck traffic down there. That's basically what a complete road life is going to look like in a rehab schedule. Excuse me, the PCC 1 millimeters, same lane width, granular, not too granular, not a granular A and B, just a granular lift. We've got a rehab schedule, short HM schedule, and a P schedule, same thing here. For instance, the difference between the top layer is 30 PAs versus 10 asphalt, which we use 10 as an example. This is the IR switched at every resurfacing. So for instance, we've got surfacing at 25 and 30. We're not doing surface. Well, here at 25 and 30, and texturization at 25, and we're saying it's taking off 5 years each time you do that. So with a 200 millimeter layer, this phase we had 195 millimeter top layer, and then the third phase we have 190 millimeter top layer. So this is complete road designs of the same functional road. It's a 4-lane, 1 kilometer road of the same, and we look at some results. So I'm going to here to the top bar, choose and click the reports box, and this is what's up. We've got project at the top here. So let's go to HMA again, and the thing we look at is the bill of materials. So with steps and all those design questions, come up with saying that this is how much of all the materials that we're using in the 50 of that roadway cycle. Coats, granular A, granular B are different super paves and asphalt sealants. If we look at the PCC bill of materials, granular, our concrete, our reinforced steel, and our crack sealant. Then is our life cycle effects. So that's what we call summary measures in here. So I'm clicking summary measures and table here and click show reports. It's a little bit small, but what we have here on the left-hand side are Tracy characterization 2.0 results from the characterization factors. Our fossil fuel consumption, global warming potential, acidification, particulate matter, eutrophication, ozone, and smog potential. Divided into different life cycle stages. We have the manufacturing stage, the construction phase, maintenance stage, and over here. These in bold are just sums of these previous columns to the left, and you see the division in the table. And we have our use phase over here, which is our annual operating energy, our total operating energy, which is the annual times the lifespan of the road. 0 at the moment. If you remember the very beginning, I'll back there quickly. At the project level, we had roadway operating energy consumption here, and that's where we could put in, let's say, the electricity for lighting. But we did at 0 for this demonstration. That's why those numbers are 0. And then we have the IFX here. Total is our totals here plus our use totals here, and that gives us a total column. Go up a bigger size here just to show it here. Trace by different life cycle stages, so you can whatever results you're looking for. If you're only looking for the initial construction, you're looking at manufacturing and construction phases. You'd only be interested in these totals here, and that's why the results are separated in the bases, and in case you use something other than just the total. The other way to look at some results, any serious analysis of these roads, you're doing this with these. I would suggest you go up here, you export the table to Excel, and do your comparisons there. But we do produce some graphs. We can produce some graphs of these results. We can compare two projects. So up here under comparison graphs in the reports box, I choose my HMI PCC roads here, and I can choose all of these. I'm just going to choose a couple: fossil fuel and global warming potential, and I'm going to show these graphs. And here we have a graph, and our results divided life cycle stages of this is HMI road, and this is the road. And look here. I think I ignored the PVI effects. Go back and unclick Ignore PVI effects. There. Come on. There we go. So now we have PVI effect from the HMA road. We have PVI effect from and the same all the other. Manufacturing versus manufacturing, maintenance versus maintenance versus the construction in blue. Same thing for warming. And there's the same idea. We have a side comparison of these two projects. Now, if you want numbers for these, it's not very accurate. Idea of the relative effects of two different roads. Sorry, let's get rid of that little box there. That's the results of it all. That's those are the results you're looking for, and what you're going to be looking for, you're going to be exporting it to Excel, and comparing numbers probably in Excel for if you're writing a report or something like that. I'm just going to go back and do a couple things that I glossed over. So I'm back to project level data. I've double-clicked on a project in the tree, and this is the project here where we choose our location, etc. And here, and we hit the construction equipment tab. We have sorts of pieces of equipment for here on the left, for different activities. What we're trying out is on-site construction energy use, which means fuel consumption. Basically, we're almost all the time we're talking about use and equipment. So we got here an compactor at the top, and the days we have a usage of 0.0237 liters per ton of asphalt. Now, a variety of conditions and weather conditions and soil conditions and usage factors that numbers, and we've chosen sort of a number, but if your situation is different and you want to dig down into this, you can go change these things. And the easiest way is if you know what your fuel consumption is, you can just change the number here. So I can change that to if I want to. And there it is. Now we'll start using 0.05 for that piece of equipment. The other way to use it is if to change the number of columns to the right here. Production factor, hours per day, maintenance per hour, secondary fuel consumption. You can put numbers in there. The calculation here. So for instance, for asphalt paver, if we're doing 1,215 tons a day, if we change that to 2,000 tons per day, excuse me, 8,000 tons per day. You'll see here off with a 0.0620. If I click 0 there, and clicked OK, I should have just carriage returned. That to 2,000 and changed from 0.0 or whatever the number was. I can't remember that number now. Anyways, that number changed. That idea, you can customize this equipment. There's another tab at the top of this form, and if this is the transfer of the raw materials to your plants, basically. So, for instance, down here with bitumen, we've material, and the default distance for transporting bitumen is 300 kilometers by road, 0 kilometers by rail, and 0 kilometers by barge. Basically, the distance from Sydney to Toronto on if you know that if you're modeling in some far off place and you know that you've got long distance to travel, or if you're doing it in Sarnia and you know that the distance is different, you can go and change the number here to whatever you want. So let's change it to 500 kilometers, for instance, and then our transport data will change because we've just transported our bitumen for a further distance. Anyways, the point that it's customizable to your own situation. Look at is that I want, so modify project, I can click OK. We've changed in there. The other one to look up here is tools and product library. And this is an important one, and this is where you can make your own custom products. So basically, if you have a concrete mix design that you want to specify, and our database library, we have these things here, and for instance, we have a bunch of concretes with different, at 30 MPa with different fly ash contents and Portland lime cement, but aren't. So if I choose one of them, is the breakdown down here of that database product. If I want a little thing about this, or I want to start one from scratch, I can customize this product. So I'm going to duplicate it here. I'm going to copy, but I'm going to call it demo. Here is where I can change the density. So let's say my new one is going to have a density of 2.5 tons per cube, and let's just change this for something down here for fun. Let's say they're to 6, and fly to 3.3 to make enter. See, it's adding up here the total percentage by weight, 9.925. I think this will accept it within a 0.1 or so percent difference. Okay, it accepted it. But we can be nice about it, and until we actually get 100% up here. But this is my demo PC, and this is my new material. So if I have current material, and add any of our materials in here by clicking Insert, and let's say I want to add some additive of some sort. I choose here, I'm going to add silica. I'm going to click, it's added silica fume down here, and I get this 0.5, and that should give us 100%. And that's a new demo PC. Click OK. I've done my new material, and if I want to go back to my roadway, I go back here to, you have to go to the P because it's a concrete, so it will save to the concrete. And if I want to change this, that one we just created is available as a choice in any of the roadway elements. And I okay, and now we've used a different concrete in that road. Discussion, or for the demonstration, yeah, I'm a couple minutes over time here. So we're going to open it up to, I'm going to back to Sherry. I'll keep control, I think, of the screen, Sherry, but you let me know if there are any questions on the chat line.
Okay. I don't see any questions at the moment, but if anyone has a question, please enter it into the chat box, and we have about 10 minutes for questions